length L, resistance R. Okay, take this one. Now get into the problem. Where is resistance R? For the rod, you can show it. Here the R will be resistance there. Initially, when you switch on, the rod is not disturbed. It is there in that position, and the entire thing lies on horizontal plane. How the mg will act into the plane of paper. Current I will flow. Okay, clear this. So when a current I flows in the rod from A to O, so will there be any BL force will act as BL force. That BL force will start rotating it, and as it starts rotating, then what conditions will arise? Then the rotating rod will behave like a cell. Then EMF will be induced. Then induced current also will come. Then the resultant current will decide in what direction it will move. So initially, so the moment you switch on, so what will happen is a current I1, I'll call it. This current I1 is due to the cell. It will flow in this direction. Don't show in the rings. It's of no use. No, B bar current I. So in what direction this will experience a torque? No, B bar the current. So if you take a small element of length dx, a torque will act in this direction. This torque acting about O will make the rod to spin, will make the rod to rotate about O. As it starts rotating, the rotating rod will behave like a cell. I'll proceed to the next part of the problem. Now in the same, this is called like a motor. A motor, oh, coming ring. Now tell me like what are things I should replace this with a like a cell, no? This one. Let's go for the cell. Let me draw a diagram. A cell will come. What should be the direction of EMF induced? As the rod rotates, B bar velocity. So this should be the polarity. The cell, what it will do, it will push the current in opposite sense. So I1 is in this direction. The cell will push current in this direction. Oh, it all got messed up. Fine, all of you. So why that I1, I2? So what is I1? I1 should be strictly what I should write. I1 equal to E by R. That resistance also I have to show it. I'll show that resistance R here. Then what is I2? I2 should be E by R. What is E? B omega L square by 2R. And what about the angular velocity? Angular velocity of the rod will be in this direction. I don't have space. I'll show it here. Tell me initially which will be greater. E will be greater than small e. So which current will be greater? I1 will be greater than I2. Tell me what happened to the motion of the rod altogether. Due to I1, the torque will be clockwise. Due to I2, the torque will be anti-clockwise. The resultant current in what direction will be towards left. Again, I'll go for one more diagram. I'm showing, let me show only this one. So the resultant, the net current in the circuit will be in what direction? Because I1 greater than I2, so the net current will be in the direction of I. The resultant current, let it be I, and it will be in this direction. Okay, now check it. The torque, it will be B bar, and the current of the torque will be, the resultant current will flow in this direction. Will there be, what type of motion the rod is going to describe? Come in order. I1, due to I1, the torque will be downward. The torque will be clockwise. Due to I2, the torque will be anti-clockwise. And since I1 greater than I2, so what will happen? The rod, the angular velocity of the rod will keep on increase. The net torque will be downward only, or say clockwise here. Where is the Lenz's law? I1 is the cause, I2 is a opposition. Able to manage? The torque due to current I1 is what? The cause will make the rod to rotate. And according to Lenz's law, the I2 is what? I2 is a induced current due to induced EMF. It should oppose the cause. So therefore, torque due to I2 will oppose the cause. But since I1 greater I2, the resultant torque will be like this only. Will be clockwise. Okay, let's come for the mathematics now. So what is asking? Angular velocity of the rod at an instant of time t. How to calculate that torque? Go back to some basic formulas I told. So what's be the torque due to this overall current? B square L to power of 4 omega by 2R. Am I right? If you can remember such things, very easy for you. Or else what you should do, assume a small element, the force acting on the small element dF, then d tau equal to dF into x, then F equal to BIL, BI dx, then integrate. Finally end up the same thing. Some of you are still asking, sir, how you're writing. I'll just show d tau equal to df into x. So this is bi dx. So this should be bi x square by 2, or the limit will be x dx 0 to L. Bi L square by 2. What is I? I is equal to total net EMF induced. So net EMF induced by the resistance R. So what is the net EMF induced? It should be equal to E minus E by R. You see net EMF induced. Net EMF induced E minus E by R. So further this I is equal to E by R, and what is B omega L square by 2R. So can you write directly this much? The answer is no. Problem to problem, things will change a little bit. This is torque due to induced current only. If you substitute, you'll get torque due to induced current. There'll be torque due to what? Applied EMF. Torque due to applied EMF. So therefore, you have to be very careful about what I said, like will help you. Slightly it should be modified. I'll take it out this. Now come for this one. So what is the net torque should be equal to? Net torque. So there's a formula BI L squared. So here you are going to substitute here B L square by 2 in place of I, E by R, B omega L square by 2R. Now write I equal to alpha d omega by dt will be the required answer. ML square by 3 d omega by dt. Solve for omega. So what should happen to omega? Omega should increase with the time. Again, you get a equation of this thing exponentially increasing. After a long time, the EMF induced in the rod will become equal and opposite to applied EMF. The current will be 0. Or this will be terminal velocity, you can call it. So what is the terminal velocity? Directly you can write it B omega t L squared by 2. Please do learn all this. They may ask you find the terminal velocity of the rod. So directly after a long time, the induced EMF across the rod should be equal to applied EMF. Okay, see this now. So this mathematics, you have to be very careful. The induced current, there is the expression. Okay, fine now. So for in a rotating structure, and a cell will also come into picture. So go back to same motion EMF ideas is what we have applied it here. Let's come for this. Two conducting rings PQ of radius R rotates uniform in opposite direction with center of mass velocity. They're having rolling motion on a conducting surface. The potential difference between highest points of the two rings. Okay, let's directly come for this.